For those of you who don't know me, my name is Kyle, also known as StockX Capital, and I am the founder of the Swop, which is a multimedia company. And I also I did create the project called Go to Gamer. So if you guys are interested in that, you can find those on my page. And for those of you that don't understand or know what the Swap space is all about, it's a platform for us to really educate the public and kind of open it up to discussions in the IC community, and as well as other networks in the greater scope of things. But yeah, there's going to be a space where we pretty much educate the public and talk about some interesting topics in the crypto and blockchain space. Today's a really massive space, so I appreciate everyone coming and attending. In fact, my parents are tuned in, which is the first time ever, and they don't quite understand the space, and they're like, we don't understand the importance of this. And I'm like, we're talking to one of the biggest founders today. So, it's pretty surreal to have this today. So I'll leave it open to Daniel to get his intro, and we'll get Dom up here soon.
Yeah, hi guys. A lot of you guys know me. My name is Daniel. I work with the Outpost project on open metaverse, 3D interoperability, and AI technologies. We definitely, Kyle and I co-host these spaces together because we really wanted to create kind of a community curated set of educational content and also allow the floor for community problem solving and discussions and just in general give the grounds to adoption too. So happy to be here. This is super exciting. Happy to have Dom up. We've been looking forward to this, and I believe we have DFINITY here as well. So it's super awesome to have all you guys here. Thanks for tuning in, and I look forward to getting started.
Mm-hmm. And before we get going, guys, it means the world to me if you could like and share this space. Helps to get a bigger spread of reach for the audience, so we can get some more eyes and ears, and further educate the public on these discussions. For those of you that aren't aware, we had a lot of internet computer projects up in the past, notably Catalyze, Discover, Tonic. We had DFINITY Dragons DAO, and then recently had Andra from District, and we have a bunch of more projects coming up later in February. We have a pretty awesome lineup, and we'll have a tweet later. We do have Ludo coming on tomorrow, but yeah, I'll open it up and we'll get Dominic his intro. So for those of you who don't know, we have Dominic Williams, the founder and chief scientist behind DFINITY Foundation.
Hey, can you hear me now?
Yes, we can hear you, Dom.
Yeah, this is me. I'm glad to be here. How do you want to start?
Yeah, super excited to have you. Obviously, this is my first time interacting with you, and go figure, it's in front of a huge crowd. So, it's pretty funny to have that opportunity, and I'm very, very, very blessed to have this space. So thank you.
Yeah, no problem. Glad to be here.
Yeah, so I guess I'd like to start off by saying this is just as much of a learning opportunity for us. I'm familiar with the subject. I've done a bunch of digging into it. Kyle and I have watched a lot of your past speeches and conferences and the research you've put out. We've read the white paper. We've read a lot of articles and stuff, and we're super excited to learn more from you, man. So thanks for being here. And
yeah, sure.
So we'll dive right in. The first thing I guess I'd like to ask is some basics. So what is proof of useful work, and how do you think it differs from the commonly known proof of stake and proof of regular work?
Well, the way that we name these schemes in the crypto industry is a little bit confusing. It started really with Bitcoin, because proof of work is both a membership system and what you might call an anti-Sybil scheme, and also a consensus protocol. So these two things do different things. A consensus protocol helps a decentralized network or just a distributed network, helps the individual participants reach agreement on something like the order of transactions that have been processed by a blockchain. And obviously, the order of the transactions that are processed and the order of those transactions is very important. Everybody has to agree because, if you change up the orders of the transactions, things like double spends happen. Like, I might say that I'm going to I paid you 10 Bitcoin, and you might give me something in return, but it might turn out that if the transactions could be reordered, I could quickly send those 10 Bitcoin somewhere else. So the transaction to try and send you 10 Bitcoin would fail. A consensus protocol sorts that out. It helps a distributed network, in our setting, a decentralized network, agree upon some data set. It doesn't have to be ordering of transactions, but it just as well might be in a blockchain. Now, all consensus protocols have what's known as fault bounds. That is, they guarantee to work in the presence of faults. A fault could be some of the participants going offline. It could be some of them behaving maliciously, trying to corrupt the protocol. It could be that some of those malicious nodes collude with other nodes, right? But a consensus protocol, or a Byzantine fault-tolerant consensus protocol, to be more precise, provides these guarantees that so long as some proportion of the participants, i.e. in the blockchain setting, some proportion of the network isn't faulty, that means, isn't offline or controlled by an adversary, it's making it behave maliciously. So long as the proportion of faulty participants is below some threshold, such as a third, then the consensus protocol guarantees that everybody will reach agreement on the same facts that need to be agreed here, typically the order of transactions. So that's what a consensus protocol does, but it has this, reliance on this assumption about the fault bound, right? So, if the fault bound is a third and more than a third of the participants, the nodes, are faulty, then, the consensus protocol can be broken. Doesn't make any guarantees that everybody will agree the same thing and so on. So in a decentralized network, you have to find ways of preventing the bad guys just adding more and more nodes until such time that they've overcome the fault bound and they can break the consensus protocol and make the network do bad things. And that particular challenge is often referred to as Sybil Resistance, creating Sybil Resistance. And the word Sybil is just a silly word for, a malicious node that somebody might add. Now in Bitcoin, of course, with proof of work, the rate of hashing actually sort of acts as a proxy for the number of nodes. So instead of counting nodes, you count the number of hashes being done or by application. So Bitcoin, when Satoshi designed Bitcoin, he had to solve these two different problems. Like, okay, on the one hand, I want to create this decentralized network. How do I make sure that the bad guys just can't come along and add nodes or other kinds of participation in such numbers that eventually they overcome the fault bound of the consensus protocol and can make the network do bad things, such as, for example, even, rewinding and replaying transactions in a different order to do double spends and things like that. So the solution that he found, is proof of work. And actually, in this first form, the Sybil Resistance, mechanism and the consensus protocol are very tightly coupled. They're really, both part of this single proof of work scheme. And proof of work is essentially a hashing competition, right? So everybody wants to add a new block of transactions to the blockchain, and i.e. extend the sequence of transactions that everyone agrees has been processed. And in order to add the next block, which also allows you to give yourself a block reward, you need to essentially find a nonce in your block of transactions that will result in the hash of the block, starting with some number of zeros. So that sounds a bit weird, but a block obviously is really just a data structure. It's like a record with a bunch of fields, right? And one of the fields in the block is a thing called a nonce. It doesn't have any purpose other than for trying to find a winning hash, if you like. And you can just set this nonce to anything you like. And what you're hoping to do, of course, is find a nonce that will result in the hash of the entire block having some particular pattern. A hash is this thing that takes an input and produces a random output. You can't predict what the random output will be without trying it. So, let's say you've got a block of transactions. You want to know what the hash of the block is. You actually have to calculate the hash. You can't predict it. There's no shortcut. And so, a hash is just a long number, a very large number. And in Bitcoin, difficulty, if you like, is defined by the number of leading zeros you can get in that big number. If you can imagine a hash as a long string of bits, what you're doing is you're spinning this nonce in your block, in this record, and calculating the hash and seeing if it's got some leading number of zeros. Now, there's no shortcut. If you want to find a hash with these leading zeros, you just have to do it by brute force. Spinning the nonce, trying different values and for the block and hashing it and seeing if you just happen to get a hash with this number of leading zeros. And if you find such a nonce and the hash of your block has this number of leading zeros, specify something called the difficulty, you can now propose that block to the network. And, usually, if you've met the difficulty requirement, that's the only block that gets proposed, and your block gets appended to the blockchain. Everybody can agree once that's been buried sufficiently that, that's permanent part of the chain. You get to keep the block reward you gave yourself inside, and you've extended the linear list of transactions that everyone in the network agrees has been processed. So, two things are happening at once. Sybil resistance is occurring because in order to find a block with, whose hash has got these leading number of zeros, you have to try a vast number of different combinations of the nonce. And so, what you're doing is you're spinning that nonce, hashing the block, seeing if it matches. And in the Bitcoin network today, I don't know what the current numbers are, but I can imagine you'd have to try trillions of combinations before you actually find a nonce that gives you a hash of the block that has the leading number of zeros that you need. So that's expensive to do, right? So, if you want to, in effect with this scheme, the relative proportion of blocks that you add to the chain, and therefore your relative share of the block reward that's being dispersed by the network, is proportional to the number of hashes you're performing, i.e. the number of different nonces you're trying. So, the game really is to do as many of these hashes as you can and as efficiently as you can. And for that purpose, you need to get some mining hardware. Like typically today, it used to be at the beginning, everyone was just doing this with a PC or something. But today, to have any chance really of competing with the other people, trying to add blocks, you need to get some special hardware. It's called an ASIC, application specific integrated circuit, that just is specialized for calculating hashes as efficiently as possible. And not only do you need to invest in this hardware, which is going to be fine, performing this hashing, you also need to power that hardware. So if you go inside a Bitcoin mine in Inner Mongolia, say, you'll find, it's like some huge, enormous warehouse. I mean, these things are often built on a colossal scale, to the extent that you'd look down the sort of corridor through the middle of all the machines, the mining rigs, and, almost sort of disappears on the horizon. And you've got all these like specialized mining rigs, which are just these ASICs, performing zillions of hashes, and they obviously consume a lot of power. So typically, they're situated next to a coal-fired power station or something like that, and that's how they're run efficiently. And the result of this is that the consensus protocol, the proof of work consensus protocol used by Bitcoin, arguably has a fault bound of 50%. It's not actually quite true. Turns out it's probably near a third, but anyway, theoretically, has a fault bound of sort of 50%. And an adversary that wants to break the network by adding, if you like, here it's not nodes, right, but hashing power in a way as a proxy for nodes. An adversary that wants to break the network by overcoming the fault bounds of the consensus scheme has to, acquire 51% of the hashing power. And that would be extraordinarily expensive. The adversary would have to buy these machines. Actually have to buy these physical machines to, in order to be able to produce these hashes efficiently and have a chance of getting 51% of the hashing power. They'd have to install those machines, which in itself is an investment, in some building somewhere, and have some way of powering those machines. So, by merit of expense, proof of work makes it too difficult for an adversary to, if you like, add Sybils, right? Add, nodes or whatever's been counted, votes, whatever's the means of participation, the metric for the means of participation is just too expensive. Acquiring 51% of the Bitcoin hashing power is just infeasibly difficult. So it's Sybil resistant. Now, what's confusing is that that Sybil resistance scheme is also sort of plays a key role in the consensus, the means through which the network reaches consensus. So when I mentioned that a hash is a random number, you can take any input and when you calculate the hash of it, right? Whether that's a block of transactions, a file, text file, a video, whatever you want. Whenever you take the hash of some input bytes, the output is completely random. There's no sort of connection. You can't look at some input and say, well, that's likely to produce a hash like this. So it's a random number, right? And so the process by which people find, by which people propose blocks, which have a hash with leading numbers, that's a random number generation system, right? Everybody's beavering away trying to create a random number with a specific criteria, and then, they find it randomly by brute force in proportion to the number of tries they have, that they make. And that random number, if you like, in a way is a means of electing a leader, right? So if you're a Bitcoin miner, you've got these machines hashing away, burning electricity, and now, through, brute force effort, you find a nonce value for your block that results in the block having a hash with these leading zeros. In a way the network has randomly selected you to propose a block that more times than not will, be added to the blockchain unless somebody else found a block at the same time. And then there's a kind of fork and that has to be resolved. So in proof of work, these things are very, the anti-Sybil scheme, the scheme that, the system through which the network makes participation expensive to prevent the bad guy just overwhelming the network and taking control. That Sybil resistance scheme is very tightly interwoven with the consensus mechanism, which here isn't a traditional consensus mechanism. It's a blockchain, which is not non-deterministic in the sense that as a block is buried, it only becomes final with increasing probability, which is a bit different to traditional Byzantine fault-tolerant consensus protocols. But these two things, anyway, are very, very closely linked. As time went on, people realized that, this scheme's always going to be very expensive because in the end, the cost of the hashing done, when, calculated, by the cost of the special equipment involved, installing, running, managing that equipment, and the cost of electricity, powering it all. That overall cost, expended by miners, over the long term will tend towards the value of the block reward. So if the value of the block reward is very high, an awful lot of money is going to be spent on ASIC hardware and I think, more pertinently, given the state of the world today, electricity, which of course, represents, carbon emissions. So, for reasons of cost and, protecting the climate, people began to, look into different ways of doing things. And back in, 2013, people were already talking about, proof of stake on, Bitcoin talk. And the idea was, well, couldn't you have a system where people deposited cryptocurrency and that cryptocurrency became a sort of, if you like, a proxy for the expense involved, the proxy for the expense involved in Bitcoin mining, that would provide Sybil resistance. And, the idea was that, different nodes or validators, as they call them, proof of stake, would have different amounts of stake associated with them. And the validators that had, staked more capital would have a proportionally greater chance of creating the next block. And the consensus mechanism now is kind of, further away, right? Because once you've got a proof of stake network, you've got all these, nodes that are participating in the network. And, while it's true that you'd want a node that has staked more to produce more blocks, the actual, mechanism can be very far removed from the actual concept of staking. So the consensus mechanism can be very removed from the concept of staking. So for example, if you look at Ethereum, it uses this, beacon chain, which is a sort of mechanism for producing random numbers. Actually the structure of Ethereum 2 really resembles, sort of early DFINITY designs from 2015, which were indeed meant to originally result in Ethereum 2. The difference being that, the internet computer uses, cryptography to generate random numbers. And I think the beacon chain still uses a kind of commit reveal scheme. But then you've got this separate mechanism now for producing random numbers, and those random numbers are now sort of selecting committees of nodes that are part of the network thanks to, maybe you shouldn't call them nodes, right? Because they run on the cloud oftentimes these days, but call them validators. The random beacon is now selecting random sets of validators that sort of form a committee that produce the next block. And, that committee can run a traditional Byzantine fault-tolerant consensus algorithm, or protocol, I call it, to choose and finalize the block. And so, what we're seeing, of course, is that the Sybil resistance mechanism and the consensus protocol, are now much less tightly coupled. And that's a good thing, actually. I mean, look, Satoshi made a huge breakthrough, but, obviously things evolve. I think Bitcoin can stay like Bitcoin and, be speeded up by layer 2s, but or indeed the internet computer. But if you really want to produce a sort of highly performant world computer, for example, you really want to separate the Sybil resistance mechanism from the consensus mechanism as much as possible, decouple them, and that will allow you to address the two different challenges, as optimally and with as few compromises as possible. And that's certainly what's happened with the internet computer. But when we talk about the internet computer implementing a scheme of proof of useful work, primarily that refers to the scheme through which node machines participate in the network, and the means through which Sybil attacks would be prevented. But it's much more nuanced. If proof of stake networks are more complex than proof of work networks, a proof of useful work network like the internet computer is far more complex than both. And that's just an inevitable facet of the pursuit of the challenges involved in creating a world computer. Like, everything has to get faster, more efficient. We have to provide more capabilities such as, smart contracts that can serve web and things like that. And so it's absolutely inevitable, of course, that over time these things get more complicated. But I think it's perhaps we should, having sort of reconnoitered what exists today and the history of it, think about how proof of useful work, as implemented by the internet computer network, works. And I think we should just start by mentioning that, rather like Bitcoin, the internet computer is created by nodes, not validators, and it's created by dedicated hardware. But instead of having machines, ASICs that do hashing, you've now got these things called node machines that are dedicated to processing blocks of transactions and smart contract computations. And these devices, are built to a specific spec. And the question I think here, which is really interesting, is how can you move from a system like Bitcoin, which forces everybody to compete to perform as many hashing, as much hashing as possible to gain a share of the block reward, which is inherently obviously inexpensive, right? Because the more hashing you do, the more blocks you produce. So inevitably, it's essentially a kind of electricity burning competition, right? Once everyone's got the same ASIC hardware from Bitmain or something, whoever has the ability to burn most electricity will get the most blocks. And obviously, the lower the cost of electricity, the more profitable you are. But it's essentially an electricity burning competition. And that inevitably, of course, will result in the cost of the ASICs and the electricity being burned equaling the cost of the block, the value of the block reward. And if the value of those bitcoins in the block reward becomes sufficiently high, you're going to be burning a lot of electricity. So that's obviously not something you'd want to replicate in a world computer, which has to run extraordinarily efficiently. And so the question is, if Sybil resistance is obtained through making participation expensive, how is the internet computer going to obtain great efficiency in that way? And proof of useful work therefore takes a different approach. It's not a competition. The node machines, which are organized, and this is another layer of complexity, the node machines which are organized by the network nervous system DAO, which controls the whole network, are grouped into subnet blockchains which get combined into one master blockchain. But when they're grouped together, those nodes are required to actually produce, if you like, the same number of blocks as the other nodes in the cohort. So the nodes These node machines are built to standard specifications. They run a perfect random beacon, called the threshold relay, which is to the day the only perfect random beacon in the world. It's the only truly unmanipulable, unpredictable, unstoppable source of randomness, and that randomness will can't be manipulated by the nodes, obviously, in the subnet blockchain, and it selects individual nodes in these subnet blockchains to it says it creates a priority order of nodes in each round, and ideally the node that's at the top of that order produces the block. But if it's too slow for some reason, it just fails over, and the next node in the order will maybe have a go, right? So the thing is there that the random beacon is perfectly fair, and if you've got sufficient bandwidth, and if you've got and if your node has been built to the correct standard specifications, so that it's got exactly the same abilities as all the other nodes, the same capacity for processing blocks and the protocol and smart contract computations, it should be able to produce a block every time the random beacon puts it at the top of the order. And the job of nodes is to do exactly that, to successfully produce a block whenever selected effectively by the random beacon, and not deviate. Now, if you built a node to a higher specification, it wouldn't help you, right? So let's say instead of building one of these node machines, they're pretty expensive at the moment, like 20 grand to build. Instead of building one of these standard node machines, you brought along some supercomputer. Wouldn't give you any advantage at all, because the random beacon is deciding when you get a chance to produce a block. So you're not going to be able to produce any extra blocks. But on the other hand, if you produce, instead of building your node to the standard specification, you decided to save some money because you don't want to spend 20 grand building this thing, and you built a substandard node for 10 grand, say, if the network's under load, you might not be able to keep up. And that means, you won't be able to produce a block when the random beacon selects you. And obviously similar things can happen, for example, if the node didn't have sufficient bandwidth available. And that means that, your node is going to, statistically deviate from the norm. And essentially the network, requires that you don't statistically deviate. And, the Internet Computer Network is controlled by this thing called the network nervous system, this kind of DAO that's integrated with the protocols. Something for those of you who aren't really familiar with the space, it's a real DAO. I mean, I don't think I'll be unfair saying there aren't really many real DAOs in the world. There are lots of things which are more like social constructs, like that, ApeCoin thing where, someone posts some text and then people vote on it. And if it gets enough vote, the idea is that, the developers are meant to sort of follow the instructions. When I talk about a DAO, I have a very different kind of thing in mind. A DAO for me is a decentralized autonomous organization that, actually, makes decisions and takes actions automatically. So the Internet Computer Network is run by this thing called the network nervous system, kind of advanced DAO. People put proposals in and so on. When the proposals are adopted, it actually executes them automatically, such as, upgrading the protocol. If a proposal goes into the network nervous system to upgrade the protocol, it actually installs updated software on the node machines. So the whole thing runs under the control of the network nervous system. So,
is there a way that you could explain to me the difference between the like a governance mechanism and a consensus mechanism, and how proof of stake? Because if the NNS would you consider the NNS proof of stake, I guess, would be my first question. And what would that lead to on the side of controlling node software?
Well, the node nervous system DAO is definitely not proof of stake. I mean, you can it's true that you can stake ICP within the network nervous system. But really you're just locking governance tokens to participate in voting. The network nervous system is, a DAO that, although it's integrated with the protocols, kind of runs above the low level network layer, right? I think in the end, you're going to see every network doing the same as us, right? Here's one of the funny things with DFINITY, right? You'll see that, we do things, people say, well, that's rubbish. And the reason they're saying that's rubbish, of course, is because it's difficult to do. And then, some years later, eventually they kind of catch up. So, for example, we have this thing called reverse gas. Everyone's going to do reverse gas. Near is spending an awful lot of money on R&D trying to get that feature out. People say that, having a DAO running your blockchain is centralized. Well, it's obviously completely the opposite, right? It's a decentralized, autonomous organization. Much, much better than having like a bunch of insiders working at a foundation or even worse, a company, right? Like Solana Labs or Avalabs. That bunch of insiders sort of coordinates all the people, running validators whenever they need to upgrade or want to upgrade the protocol. It's much better to have a decentralized autonomous organization controlling a network. So, everyone's going to do that, right? So if you look at Ethereum, look, there's a concept of slashing, right? If slashing involves like backroom coordination between people running validators, and all the people being on validators being part of some Discord group or something like that, that's going to be very, very cumbersome. That's no way to scale a network. So in the end, Ethereum will have to try and automate all of that too. So all of these things, reverse gas, DAO, all of these things the internet computer does, will eventually be seen in other networks, just in the same way that, the Ethereum 2 is really a sort of early 2015 DFINITY design.
It's definitely new.
It's
super awesome to see like what you guys did with it, because it really is something truly unique if you break it down into the layers. Like it's really impressive, man.
Yeah, no, thanks. Look, the network nervous system, it's one of those that sounds easy to do, but actually to make it work in production is very tough. So, back in 2015, I think it was 2015, I was with this dude I was working with, a guy called Gustav Simonson, who was one of the early Ethereum core devs. And, it was in this, company, Coinify, that became Stringlabs. And, we basically credited, it was such a primitive thing, but it was like a special governance smart contract, right? And then we created some privileged opcodes that only the smart contract without ID could, run. And then this was obviously controversial, but just a very proof of concept, thing that, you could, do various things with the network, just by having the smart by calling functions in the smart contract. But it was just like a proof of concept where you could have a special smart contract with special privileges, can even run special opcodes and things like that. But that, it's like there's an expression in Silicon Valley, never mistake a clear view for a near thing. Right? It's all very well being able to see that these networks should run under the control of a DAO, but that doesn't mean it's a near thing. It's very, very difficult to do. Because of course, you've got to sort of, the governance system itself needs to be upgraded, the network needs to be upgraded. In the case of, sort of infinitely scalable network, or a network that can scale without bound, which is more technically accurate. You've got like all kinds of things going on, nodes being added and removed from subnet blockchains being combined, and all kinds of other stuff. And so, that DAO is actually going to be fully integrated with the protocols, and, things can't go wrong. It's a blockchain, right? So it's a very tricky thing to do. And I think that's one of the, biggest, achievements of the team and the DFINITY Foundation was making that work and keeping it going, right? It's
it's a phenomenal system. It seems to be doing pretty well for itself. It seems to have a lot of people interested in and engaged in the governance so far, at least for the most part. And I'm really interested to see how it continues to go at scale. It's going to be it seems to be just as much of a technological thing as it is philosophical. And
Ha.
it's just like one of the most like brilliant things I've seen be done so far.
It's going to keep going. It's going to keep, look, I mean, democracy is always, messy, right? So there's always going to be people, there's going to be different, proposals being put in that sometimes contradict each other and so on. And there's going to be arguments about which ones the network nervous system should adopt and who's got the most voting power. I mean, that's just democracy, right? It's a messy thing. But, the network nervous system, has processed hundreds of proposals now. And that's provided the, internet computer ecosystem with a huge advantage because it's meant that, the cryptographers and researchers and engineers, at DFINITY and actually sometimes externally have been able to, just push a lot of improvements into the network. I haven't had time to actually follow this as much as I'd like, but someone said, the other day that, the internet computer does 2 hard forks a week, right? and that's, if you go back to the original, proposals talking about the network nervous system or the blockchain nervous system as it was once called, there's this idea that you can produce an adaptive network that just evolves very, very quick. And look, we want to do big things, right? We want to create a blockchain singularity. We want, blockchain to become the everything computer that everything is built on. And so we haven't got time to mess around with, coordinating, the community hasn't, everybody says, hey guys, we propose we upgrade this software. Okay, it's going to be complicated. We've got 6 weeks. I mean, that's not going to work, for something of this level of ambition. And also, obviously it's kind of antithetical. I mean, Bitcoin is different. Bitcoin's an incredibly simple protocol, right? So it's okay that it's just digital gold. And it's, the first cryptocurrency and it's okay that it evolves very, very slowly and that, somehow there's this community thing with, the miners sort of slowly agreeing and things like that. But albeit Blockstream has obviously a very big role to play in that. So it's quite centralized, but, it's kind of okay. But once you get into the realm of general purpose blockchain, there just has to be a better way of doing it. And this is obviously the only sort of obvious, way of creating an adaptive blockchain. You've got 2 choices. Either you have like a company, like Solana Labs or something, or Ava Labs, basically dictating how everything goes and coordinating people behind the scenes, or you create a centralized autonomous organization. And I think obviously that's the way to go. And what's I think important with respect to proof of useful work, what's important about the network nervous system is that it's responsible for slashing. So, you could, of course, I talked about nodes. Nodes are meant to be built to this standard hardware specification. And, so long as they've got enough bandwidth, and they're just, running as they're supposed to run, they're not going to fall behind. They're not going to statistically deviate. They're going to create the expected number of blocks because the random beacon is completely provably unfair. Sorry, not unfair, fair. That'd be very bad, right? Provably unfair. No, it's actually, it's the only provably fair random beacon in the world. It's completely unpredictable. So, so long as, you built the node to the correct spec and it's got, available bandwidth and things like that, it's not going to statistically deviate. But of course, let's just say, the node wasn't built to the standard spec and it didn't have enough bandwidth. It's going to statistically deviate. It's not going to be able to keep up and it's going to not produce as many blocks or maybe less transactions in the block, whatever, right? So then you get to the thing like you've got to slash the node. And, modern networks which decouple, the Sybil resistance from the consensus process, need to have this concept of slashing. Like what happens if one of the nodes in the network isn't doing its job? We need to slash it. Now, with proof of useful work, you could completely automate it and make it very simple. You could just say, right, if a node statistically deviates, by this much, and you could just, mathematically define what that means. If a node statistically deviates, it doesn't do what it's supposed to do, essentially, right? And it doesn't do that consistently, okay, there was a blip, but, they didn't have enough time. They hadn't, whoever the node operator, whoever owns that node had enough time to sort it out, right? So you could devise some scheme that just says, right, automatically slash that node and just knock it off the network. And the internet computer, one of the cool things about it has this thing called chain key, but the subnet membership is dynamic, and you can add and remove nodes without interrupting its operation. So you could just have a scheme where, right, proof of use will work, you can't statistically deviate, your job is to produce exactly the same nodes as all the other nodes, exactly the same amount of blocks and perform exactly the same amount of computation as all the other nodes. For some reason you're not producing enough blocks, slashed, right? But that'd be a kind of, you could do that, but that's not really flexible enough. Imagine someone's got a data center, imagine someone's running nodes in Singapore, just say, right? And, it's great that people are running nodes in Singapore. I think there are nodes being run in Singapore at the moment. But imagine that, some deep sea trawler pulls up a whole bunch of undersea internet cables, providing connectivity to the data centers in Singapore generally. Just some kind of freak event. Well, I'm sure there are backup routes and all the rest of it, but essentially the nodes in the internet computer nodes in the Singapore data centers in such a situation would begin to statistically deviate. It wouldn't be their fault, right? So if you completely automate slashing, the danger is something like that happens, all the nodes in Singapore data centers get slashed. So leaving the slashing up to the governance system, the network nervous system is a better, much better, option. But, I think it's fundamentally you've got though still, it's a proof of work scheme in the sense that, to participate, you have to acquire dedicated hardware and in fact specialized hardware, and operate it correctly. And that does actually provide a number of advantages.
What kind of, by the way, I didn't mean to cut you out. What kind of specialized hardware, do you think? Like what kind of, I've looked into it a little bit, but I'm interested in, what exactly makes the hardware specialized.
So, obviously they're built from a, if you like, you can think of it like a base configuration of a typical blade server, right? But the difference is that, it's a bit like a Google node, right? Within Google, they have lots and lots of, blade servers, but, those individual machines, have a specification, have a design that is optimized for the kind of distributed computing that they do. And, among those optimizations, the machines don't have any redundancy. So, for example, you wouldn't have a redundant power supply. And the reason for that, of course, is that the network itself, the distributed system, has redundancy. And that's the same with the internet computer. You have a decentralized network, and, the liveness, the liveness, the property of the network working correctly and, doing it, continuing to do computations and the services running on the network, continuing as expected. Or, for example, if you're interacting with a social network, you can still post the message and stuff. That liveness, property doesn't depend upon individual node machines being reliable, right? It depends upon a sufficient number of node machines which are run by independent parties in different data centers in different parts of the world and different jurisdictions. It depends on a certain number of those node machines continuing to run. And so obviously, that'd be the first and most obvious difference. These node machines don't have things like redundant power supplies or RAID arrays. Typically if you buy a server machine, if you're a corporation, you buy a server machine, you'll use something called RAID to combine lots of different hard drives, so that if one of those hard drives fails, the sort of virtual hard drive created by the RAID system continues functioning, right? So node machines don't have anything like that. No redundant power supplies, no RAID systems. because it's the decentralized network that provides the redundancy, not the individual machines, not the individual even node providers. And then the internet computer hosts these things called active smart contracts that can run in parallel deterministically. And each active smart contract, we call a canister, is actually a bundle, which has nothing to do, by the way, with Kubernetes or anything like that. It's just what we call a smart contract. Each canister smart contract is a bundle of WebAssembly and persistent memory pages that it runs within. So, we obviously care about the efficiency of these memory pages, which are persistent. And so the node machines don't actually have, well, it's not quite true. They don't, to begin with, they didn't have any hard drives, right? It's just NVRAM, which is this like non-volatile memory. It's more expensive than an SSD, right? Which is like a solid state hard drive. But it's much more performant. And now there've been there's new node machine specs, and because everyone has to the network will only combine node machines that are built to the same standard spec. Now there are SSDs being added to these, and that additional sort of available storage capacity will be used for something called immutable storage, which is going to make it much less expensive for people to do things like video streaming, decentralized YouTube, for example, on the internet computer. So what else is there? Oh yeah, then there's also, there's a thing, there's like Rome Epic chips, or they Milan now, and it's like AMD chips. They have this thing called SEV, Secure Encrypted Virtualization. And we actually have that in all the existing nodes, but there's a new version, there's a new node machine standard, where instead of having something SEV-ES, encrypted state, it's SEV-SNP, forget what it stands for. But essentially, that makes it possible to make the nodes a black box, right? So, say for example, you're a node provider, as they're called, like somebody who's, acquired a bunch of these node machines or built them or whatever you've done, and you're running them in data centers. And then you realize that your node machines, some of your node machines are in a subnet, right? You don't control it yourself, obviously, it's done by the network nervous system, but some of your node machines are participating in a subnet that's hosting some smart contract, canister smart contract that's got some data that you want to sort of get a peek at, right? And so what you do, you go into your data center and sort of you'd have to open up the machine and look at just take a copy of the data and the NVRAM and so on.
Hey, Dom. Sorry.
The SEV is a black box, and you can't do that. SEV-SNP prevents you doing that. It kind of creates everything's inside a kind of secure enclave, and that means that even the node providers, people with physical access to the node machines, can't see the data. So that's another example of a difference between a node, a kind of special hardware feature that's required.
Yeah, that's like kind of that was the key point I wanted to hear, was more about the on the side of especially the node providers being able to see the data on the actual nodes and it being encrypted or unencrypted. So I'm really happy to hear that. That's like super awesome.
It's another topic, obviously, privacy, but I mean, you've got different levels of privacy, right? I mean, today, most node providers are completely honest, right? They're not looking on node machines to try and see what's inside, private smart contracts, right? But it does depend on trust. And by the way, when you run systems on Amazon Web Services, that also depends on trust. Like, there are people who work at Amazon Web Services. So, but okay, so that's what you have now. The second level, obviously, is just like this SNP, SEV-SNP, which will effectively make it extremely hard to get at that data. Like, you have to have a lot of very special skills. And if that doesn't satisfy you, well, obviously you can just use pure cryptography. Like, there's some demo thing called IC Vault. And, I can, for example, like a file, you could create like a Dropbox on the internet computer. And what you do is you'd encrypt all the files, that you upload, but you do it in such a way that you could instruct, the smart contract to re-encrypt that file to someone else's public key. and it never goes through plain text. So for example, I could upload the file in encrypted form onto this Internet Computer Dropbox, and let's say I wanted to give you access, right? You give me your public key, and I tell the smart contract to re-encrypt it to your public key, but it never goes through plain text. And that obviously gives you, absolute security. So, I think with all of these things, there's like a spectrum, right? And it very much depends on the use case, right? The trade-off.
Hey, Dom,
The trade-off.
I know you've only got a few more minutes. I wanted to give the Swoop to see if they had any closing thoughts or closing questions they wanted to ask.
Sure.
Yeah, thank you. So yeah, Dom, you actually answered a lot of my questions. And when I previously looked at your, when I researched more on you in the past, I believe it was like 2015, you mentioned the 3 E's of Sybil attacks. And, I know you kind of touched on it on, what that is, the internet computer. But do you do you remember like what those are called? Like it was like entry.
You have 3 different kinds of, you have 3 different forms of Sybil resistance, right? There's, the 3 E's: entry cost, existence cost, and exit penalty. So if you look at something like Bitcoin, well, entry cost is obviously, the requirement to purchase effectively this hashing equipment, these ASICs, these mining rigs, right? So you've got to invest some money buying those mining rigs. And then once you've got those mining rigs, you've got to, set them up so they can work, right? Now, at a large scale, that's very expensive. You need like some warehouse somewhere, and you've got to pump all this electricity in and things like that. So, setting that up is, the entry cost. Then you've got existence cost. Now that's the cost of making these machines run. And, obviously the main cost will be electricity in the case of proof of work. But you still got to have like staff running around maintaining these machines and so on. Maybe if it's a very expensive, mining operation or a very large mining operation, you need security, security staff to protect it. So all of that is existence cost. In the case of Bitcoin, you don't really have much exit penalty. I mean, arguably the exit penalty is, you've got to sell your mining rigs and you're going to get a much worse price than you paid for them. And you've got to sort of get out of all your contracts for bandwidth and all that kind of stuff. So there is some exit penalty, but you can make it kind of higher. If you look at proof of stake, the entry cost is the capital, right, that you've staked. And that's, can be made arbitrarily large, right? That's one of the nice things about proof of stake. You can say, right, if you want to add a validator, it's got I think Ethereum is like 32 ETH, is it? Or something like that? I forget what it is now. But there's some minimum number
that's quite ridiculous, actually.
There's some minimum number of ETH that you have to stake to create a validator. And they've still got like 500,000 validators, which don't get me started on that. Like it's very expensive to put it this way. It's very expensive to replicate computation and data across 500,000 validators, which for the most part are all running in the cloud anyway, so it's not decentralized. It's just 500,000 replications of data and computation. So I think there's some work that needs to be done there to force some of these validators off the cloud. But I mean, one way of thinking about it is, although this isn't hardware, right? And this is part of the problem, my problem with proof of stake. Essentially it's just like this, software instance that's spun up on a virtual computer on Amazon Web Services or Google Cloud or Hetzner or something like that. And as we've seen, like the cloud can just switch them all off. Like, a few weeks ago, Hetzner decided they didn't want Solana nodes anymore, and they literally just, ran a script, found out which nodes were running Solana, pressed a button, and more than 1,000 of them just went offline in the blink of an eye, and that's like 40% of the network just disappeared. So obviously it's not decentralized really. But, anyway, aside from that, you entry cost of stakes, the crypto, there isn't really much existence cost. You're paying for the validator. You might be, in the case of Solana, actually using a lot of bandwidth. It's a very chatty protocol. Most of those transactions, it's not, like 80-90% of the transactions they claim are actually protocol messages. Very chatty. So you've got it's consuming a lot of bandwidth. So that's your existence cost, but it's not like anything at all like, proof of work. On top of that, you could also add the cost of capital. Like, there is a sort of implied cost of capital, right? because you could take that capital and put it into T-bills and get like coupons interest effectively. And then, with proof of stake, you can do exit penalty much better. So, if somebody is doing something naughty, let's say, some, I wouldn't say minor, but, somebody runs lots of validators, decides to be evil. They go a bit too far with minor extracted value or something, which is not the kind of thing you do in those schemes. And they do something evil. It's possible, for the network somehow through some voting process, I went down in the end, but through some process to expel, that, validator operator and maybe slash all their nodes and maybe even seize some of their stake. So the exit penalty can be very, very powerful indeed.
Hey, Dom, we're at the top of the hour. I know you've got to jump. I did want to say thanks to the Swop for hosting this, and thanks to Kyle's parents for attending.
Yeah, I appreciate the shout out. One last thing, if I could get this, I guess, brought up, Dom, before we head out, is there anything that you would like to say to the internet computer community? Anything that might be inspiring or whatever to projects. I know they're excited to have you present in the community, and if you just had an overall message to share before you leave, that'd be awesome.
Look, I mean, obviously, we believe in what we're doing. We're not here for the money. We do want to be number one on coin market cap, but it's really about delivering something that's, impactful and valuable and being recognized for that. And, we're in a tough kind of position here because, the internet computer is a very potentially disruptive, technology or thing because it's a network that extends far beyond blockchain. I mean, look, our ambition is, blockchain singularity, that, everything, pretty much the vast majority of systems and services will eventually run on blockchain. There are a lot of players in blockchain that, don't want the internet computer to, become successful. That's probably the easiest way of saying it. And so the ecosystem has, sort of labored under quite a few, difficulties created by those kind of people. Like you probably noticed that the internet computer is never in the crypto press. That's not for one of us trying. We spent a huge amount on PR. We also didn't have that kind of huge amount of money that Solana had, right? So, Sam took $4 billion, $4 billion from FTX and so on and plowed it into 500 companies. And a lot of those were in the Solana ecosystem. And he's also invested in Near and Aptos and, 3 Arrows went into Avalanche and Near and so on and so forth. So, we didn't have the benefit of those kind of, FTX funds or 3 Arrows Capital funds. So we're very aware, we're just amazed and so grateful that for everybody who's had the courage, given what we've been up against to build on the internet computer. And what I want to tell people is that there is, a method, if you like, in our madness. We do have a scheme, we do have an alternative way of doing things. And this is something that we've been working towards for years and years, which is to essentially, allow people to take advantage of the crowdfunding 3.0, by running totally, fully decentralized on-chain internet services under the control of these special kind of DAOs called service nervous systems. And we think that's going to give people absolutely enormous advantages because once you run an internet service in a fully decentralized form, so it's like a protocol, it's just like the blockchain itself, you can take advantage of, advanced tokenization strategies that, you can't if you're really just building, for example, a Web3 service on Amazon Web Services and, then just keeping some NFTs and tokens on a blockchain. So we're aware of, people's need to use some of these key features and including also some of the multi-chain stuff, the advantages it's going to give people. And we're working very, very hard on getting these things to the community as fast as possible without obviously jumping the gun and allowing something to, putting in a proposal to update the network with something that doesn't work properly,
You guys have done an absolutely fantastic job, at least doing that. And in the most part, like, you guys have done a ton of research in engineering. I've had the liberty of accessing and reading a lot of the source code for the Internet Computer. A lot of its software. It's just so well built. There's a ton of engineering. You can tell. I mean, it's written all over the place. It's by far one of the most well-designed, well-structured, and powerful networks that are currently out there. And then even off the side of a blockchain network, it's extremely compute capable, and it's a hell of an experience for a full stack developer. So super, super, like, big props on you guys for doing that.
Thank you.
It's definitely been a hell of a ride.
Yeah, there's a lot of people who believe in it, and there's a lot of people who've been just working behind the scenes incredibly hard. I mean, the DFINITY Foundation's obviously built up an incredible team over time. Starting from, in the early days, like a bunch of really, really interesting characters, like, early on, Andreas Rosberg, he's on sabbatical, maybe on some things with his eyes and stuff, but, early on, he was the guy that was the sort of co-designer of WebAssembly, and that meant the Internet Computer obviously was able to take great advantage of the WebAssembly virtual machine. He also was one of the pioneers behind the Motoko language. People like Timo Hanke, who did ASIC Boost for the Bitcoin community, all kinds of Ben Lin, the L from BLS, and all kinds of interesting characters early on. But then, that over time, the foundation had to change and sort of scale up and become this pretty hefty technology organization, which was able to, combine kind of complex cryptography and research with engineering in order to actually ship this thing and get it running. And, that team is full of people really, really believe in the mission and the tech, and that work incredibly hard on it. And, it's their sort of unceasing work that's making all this possible. And, everyone right now, I can tell you, inside DFINITY, is focused on, shipping this kind of icing on the cake, if you like, these features that will really enable the community to take things to the next level, such as the service nervous system and multi-chain stuff, the chain key capabilities. And so it's all in the works. I think hopefully 23 is going to be a huge year for this ecosystem. I think it's going to be. I think once people see the power of running like internet services, like Web3 services fully on the blockchain, no cloud computing, running these Web3 services under the control of DAOs, service nervous system DAOs, in the modes of protocols as though they're part of the blockchain, so they can fully tokenize in very sophisticated ways. And once we'll see the results of like crowdfunding 3.0, when liquidity can come in from other blockchains without bridges because of chain key and things like that. And people can use things like ICDEX to actually, make these governance tokens, tradable very, very early on. And, that's going to be very big. And I think we're going to see a lot of, projects popping up all over the world that wouldn't otherwise have ever had a chance of really having a go at, accessing the global tech economy, because, it's something that really does need democratizing. And I've seen the difference between, I was in Silicon Valley for 10 years, and before that, I'm out of there now. There's a difference in terms of the capital availability and things like that. So I think 2023 is the year when it all happens, and hopefully a lot of this stuff now is days or weeks, a few weeks away. We're getting there.
No, you guys have been doing an absolutely fantastic job. And like I said, as a full stack developer, we've tested a lot of things here on the Internet Computer, and it's very compute capable. I mean, we've managed to put things on chain I never would have thought ever would have reached a blockchain. It's absolutely crazy, and the experience really isn't like, it's the candid, the interoperability, the language agnostic experience. Like, it's really, really different, even on the compute, the distributed compute side. And I'm just extremely impressed with my experience in the IC. I've been building here since Genesis. I think it's capable of much, much more. And I do think that 2023 is going to be a hell of a year for adoption, in my opinion.
Yeah, and we've also got other things as well, which I think could surprise everyone, like, wallet apps, this idea where, people install, an app on the Internet Computer, and they're the controller, like they control it. It's in their wallet, so to speak. There's no centralized parts at all. It's just fully running on it. Like, it could be like a a simple thing like an encrypted notes or something like that. But, I think there's a huge number of different wall apps that could be created. So there's a whole load of stuff coming. Also, we're going to keep driving efficiency. We're going to have different kinds of subnet, which you won't access directly, but you'll be able to tag code. That will, we want to see things like, game servers, or game server functionality, like, for multiplayer games running on the internet computer. We want to make sure that people can do, cost, effective storage for things like, video. And so it's,
we've actually done a lot of research with multiplayer servers on the internet computer, and we're very, very curious about the subnets and the specialized subnets for not only storage and like canister management, but especially things like multiplayer AI and ML compute. We're extremely excited for that stuff. So we're looking forward to experimenting as soon as it hits the ground.
We're on it. Yeah, there are people working on all these things. So, but there are some real big features coming in the very near future, so I think this year is going to be big. I think really exciting things are going to happen.
Yeah. Dom, on the Crypto Wendy or maybe it was the Anthony Day interview that you did, recently, you mentioned that the internet computer could possibly get up to billions of transactions a day, before summer.
I think it's possible. Look, I think before Christmas, it sort of went down, but I think it was like, I think we hit some days where it was doing 750 million in a day, and then it's going to come down to 400. Now it's back up half a billion. I think, things like ICDEX, like once that thing is fully decentralized, running under control of an SNS, and it's using chain key to list every sort of crypto asset you can imagine on other chains without a bridge. Because it's order book based, just something like that alone could generate a huge number of transactions. Then you've got, all these social, sort of Web3 social networks that are going to, hand over, fully propose to the network nervous system that they fully decentralize and that the network nervous system creates a service nervous system to take over. And, when that happens, I think they're going to, many of them are going to start airdropping governance tokens to users. I think a lot of this stuff could, create different kinds of frenzy. And, so I'm pretty, bullish. Going back to that thing I said before, never mistake a clear view for a near thing, right? But, crypto is very dynamic. Things can happen pretty quickly. Because of the kind of, the crypto press news embargo on the internet computer, this fucking ridiculous thing, a lot of people just don't know anything about it. Which is absurd because obviously it's one of the original crypto projects. It's the biggest R&D operation in crypto. It really is breakthrough tech. But I think that it will start increasingly to, it's the things people are building that are going to bring it to the attention of the masses, especially when people get the idea that, wow, like these services are running in a fully decentralized form. They're not on the cloud. They're fully on the blockchain. And that means they're running under the control of a DAO. There's no developer behind the scenes. He's the Wizard of Oz. You can delete your data, make modifications, steal your tokens. Imagine that, right? Like something like somebody's like, I always mention OpenChat. There's lots of like Catalyze and lots of people working on these kind of concepts. I just happen to know the OpenChat team. That your chat account is like a crypto wallet too. So you can send crypto with chat messages. At the moment, it's only ICP, but in the future, it can be Bitcoin, Ether, ERC20, NF, whatever, right? And now you just can't do that with a centralized architecture. Like if you want to build something like that on Amazon Web Services and then just keep some tokens on the chain, like getting that kind of level of integration is very, very difficult and very difficult to trust, something built on Amazon Web Services with all your crypto, right? It needs to be running on the blockchain under the control of a DAO. So I think, when people begin to understand what's happening and see that they can also participate in these Web3 services and become active users, referring other users or helping with content moderation or creating amazing content that goes viral on the service, that through that, they can, become, the decentralized Web3 service will actually sort of treat them as founders, if you like, by giving them governance tokens as rewards. And when, users realize that, you can participate in these things and become kind of founders and, effectively owners and part of the team. I think that's going to be pretty viral. That's my bet. once it gets going. I don't know how quickly it's going to take off, but my guess is faster than people realize. And that's not far away now. It's going to start happening soon. So that's why I think it's possible that we could go from where we are now, which is 500 million transactions a day, to sort of like, I don't know, more than 1 billion transactions a day by the summer. But we'll have to see, right? Who knows? Crypto winter. But I'm optimistic. I'm optimistic.
Kyle, I think you wanted to say something here?
Yeah, no, that absolutely is gonna blow my mind once we see like transaction like that. I know you mentioned in a tweet recently, it was like possible that ETH integration could come up before ETH Denver. Do you see anything big happening with that immediately once that's like capable?
Well, look, I tell you, and I can't tell you who, but we have been talking to some big Ethereum DeFi projects who've expressed interest in taking various parts of their infrastructure that currently run on cloud and putting it onto the internet computer. We haven't had time to follow up on that yet, but we will. Certainly, you can do it at the moment. I mean, we did a demo for that Uniswap demo where the front end was on the internet computer, but it was the real Uniswap. It just been migrated there, and you could like initiate transactions and stuff using II. But that in that case, what's happening is like it's using the chain key to create the Ethereum accounts and sign Ethereum transactions, but the actual transactions being forwarded via the browser and things like that. But if we do network level integration, so the internet computer nodes are talking to Ethereum nodes and stuff like that, as has been done with Bitcoin, you can do a lot more things. And it becomes much easier for developers to use. So that's what we're doing. And I don't have a timeline, but I don't think it's going to take that long. I mean, Bitcoin was really the complex one because of the UTXO model. But I think Ethereum will, hopefully be faster than Bitcoin.
I think it's good that either way. I think it's good that the engineering teams and the research teams take the time and dedication to make sure that it's done right, it's done safe. It's nice and quick. It's easy to use. It's developer user facing. I think that's important. So there's no rush on greatness, man. Rome wasn't built in a day.
Yeah. No, totally agree. And you don't want you don't want people to lose. Hey, this is fucking great. There's chain key. You can just put your Bitcoin on the internet computer, and there's no bridge. It's totally trustless and decentralized. Well, the flip side of that is obviously if the cryptography goes wrong, all your Bitcoin disappears, right? So that wouldn't be good. It's got to be done properly. And also, I mean, I don't want to get into the gory details, but the actual, the chain key crypto that's doing this threshold ECDSA and stuff like that is actually pretty complex. Like everyone knows you can do threshold ECDSA. There are threshold ECDSA schemes out there on GitHub, but the problem is they're not performant enough. The question is, how do you create the secret shares? You need to, you need a non-interactive DKG. You need to do resharing because, of course, blockchains don't have static membership. Nodes are coming and going. And in the case of our implementation, it's actually constantly resharing to rotate key materials. So if you have something called an adaptive adversary, like somebody's creeping, somehow sneaking into data centers and collecting key material from nodes, it doesn't work, right? Because the key material is only valid for a short while. So when you put all that together and the keys are also being backed up between subnets and things like that as well, just to prevent Armageddon. And that has to be done in a way that's also secure. It's actually a pretty fiendishly complicated system, and that obviously has to be implemented and made reliable, and security audited, and then on top of that you've got the APIs and the canister that's like receiving the UTXO sets and creating another sort of database over that for if you want to do like chain, CK Bitcoin, like use it as a layer 2, it's a bit quicker and stuff. And so, and then you've got the APIs for some people who do want to look at the UTXOs. It actually is pretty complex endeavor. I think Ethereum will be simpler. But it's like, we've got this chain key capability now. That's done. But, making sure the implementation's really good and solid will take time. But I would love to. I think it's, I don't want to make any promises because everyone will like be upset with me. I would love to see it done by ETH Denver, but I've actually got, and I think actually from what I've heard is it's actually possible, but what is it? ETH Denver's like March, right? And we're in February. I think, I think certainly a demo, like testnet stuff, right? Possibly. Yeah. That should be possible. And also like more, hopefully, I mean, more demos of what you can do and maybe some announcements, something like that. We'll see.
I mean, we're like super looking forward to that. I mean, ETH integration, that's going to be huge between ETH and Bitcoin. Chain key to me is the most like incredible thing. I think it's a beautiful technology. I think it's like that one size fits all glue. And it's really nice to see it come as far as it has, and then to see it be put to practical use cases is even better. So I'm really, really excited to see where that goes and how that scales. And I'm looking forward to the tooling that produces for developers to interoperate and integrate easily with other chains networks on a more layer one level rather than these layer two bridges that we're used to. So, man, it has just been like, it's so mind blowing the work that you guys have done. And we're all super appreciative of it.
Well, thank you. We're going to continue working hard. And, you know, I think the spaces, I'm happy to come on again. You know, I think that they're useful, and a lot of people are interested in these kind of like, you know, more complicated topics. I mean, even with proof of useful work, really, we sort of, I think looked at the high level, of it, but there's more discussions to be had, you know, about, what are the advantages over, for example, a network based on sovereign hardware, you know, dedicated devices versus, proof state networks where, you know, that they're running on the cloud and things like that. And, well, it was very nice for you to look into that freeze, the Sybil Resistance thing, because, you know, there's not really been much work done on, you know, not much structured thinking about Sybil Resistance, but Sybil Resistance, of course, is an extraordinarily important topic within blockchain.
I've known you research it for a really long time too. Like I've done a lot of back looking into your past research, with the sources of where DFINITY came from, more or less where your passions lied to what led to the internet computer as an idea, as a platform, and then as a product. And I was always kind of interested in how you tried to go about solving some of these issues, and the way that you attacked it from is extremely respectable in my eyes. So as far as that goes, man, there's major props to you. And if you ever feel like there's something new that you want to talk about, we are totally open. You can come up anytime. We'd love to give you space to talk about it.
Let's do it again, you know, and, you know, I just find it part, you know, obviously without the team, and actually now some external contributors, there'd be no internet computer, but also without the community building stuff, like the value in the end of this ecosystem, the reason it's going to take root and become something huge, and we're going to hopefully begin to see the realization of the whole sort of world computer vision on a grander scale, is because people have the courage to, you know, get involved with technology, try and understand it and build on it. So, you know, my heartfelt thanks to everyone here who's interested.
Yeah, absolutely.
My bad, Kyle.
I was gonna say, absolutely. Like, Dom, if you are ever on Twitter, like when we have a space, we're always going to give you a spot to speak, just so in case you want to butt in at any moment, or if it's an organized space, to, you know, be planned ahead of time. But, yeah, like any time you want to talk more with the community, we'd be glad if you did it on our space for sure.
Cool.
Yeah, I mean, you've been, your insight has been absolutely phenomenal. I respect it every time I hear more of it. There's so much research and passion behind the internet computer, behind DFINITY, behind Chain Key. Like I said, I've read the white papers, I've watched the videos, I've read the technical papers, I've dug really, really deep into this stuff. And I'm just, I'm thrilled every time I hear more about it. So yeah, please do, man. Please do speak up more.
All right. For sure. All right. Well,
at this time, yeah, I think we'll get to wrapping it up. Listen, man, I really appreciate you coming. We both do. We're definitely here to try to help with that, with providing more content and more tooling, marketing, research, all of that, to try to bring adoption here and get people to understand this beautiful creation. And at the same time, we're like ever so grateful to have you guys and DFINITY especially to come on these spaces and talk with our communities and with your communities about the things that they're doing and that you're doing, so that way we can work together to build the best solutions possible moving forward. So, like, again, super psyched. Thank you so much for coming, man. We really appreciate it.
Yeah, pleasure.
And your passion is it's inspiring, man. Keep it going.
Yeah. All right. Thanks, guys.
You're welcome. Yeah,
And,
quick.
Kyle, I'll let you.
Yeah, just quick little announcement. We do have more IC projects coming on later this month. Again, I mentioned that we have Andra from District. We're going to have Versatile, Boxy, and then I believe we're going to have a Ethereum project that's pretty big, closer towards ETH Denver. It's not necessarily confirmed yet, but I'm really excited if we can get them on.
Yeah, and we have a few others as well. We're getting we're basically gonna get community discussions, topics, things that people can all get on and talk about and propose solutions to, kind of like we did with the boundary nodes a few days ago on Thursday. That was a really awesome speaker panel. Again, thanks to everybody in that who came. We ended up solving a community-based problem really, really nicely with cooperation from all sides, and that was probably one of the most beautiful things I've seen since the town halls from Psychedelic. And this has been quite the experience. So, like, again, I really appreciate you guys, DFINITY, Dom. You guys have been absolutely phenomenal, and we look forward to doing this again for sure. And like you said, stay tuned, because we got Ludo tomorrow. We got quite a few many projects coming on over the next month. February is going to be packed with a lot of excitement for us. So we look forward to having you guys all up. And also, of course, any feedback, feel free to reach out to Kyle or I. DMs are always open. And again, just thank you all for coming.
Thanks, guys.
All righty. I'll see you guys. I'm going to end the space now. Appreciate it.